Alright, so let's carry ahead with the identity element and the inverse of an element. So when we say identity element, we mean an element that will always return the same answer every time you operate on it. And this is what I mean. Let's start with normal numbers. There's a particular number in mathematics that if you multiply by it every time, you always get the same answer, and that number is 1. We say 9 times 1, you get 9. We say 8 times 1, you get 8. You get 0 times 1, you get 0. That one is the identity element. Do you get that? It's like the identity elements. But when you're talking about binary operation, we're not exactly saying addition, subtraction, multiplication, and division. We are talking about a particular operation that has already been defined for you. So how do we have this work out here? So let's say we have this let's say we have a particular custom operation called asterisk, and we have a number, an operator called x, for example. So for the identity element, if you have the x operating on, let's say, like asterisk on e, you will always get x back because e is the identity element. So we say let e be the identity element. So we have x with e, you will get x back, or if you get e with x, you will get x back. Do we get that? So that's about the identity element. We need to be able to look for the identity element and find what it is. And let's start with some simple examples. Let's say, for example, let's say this one. It said let asterisk be an operation on this set R of real numbers defined by a asterisk b equals to a plus b for all a and b members of the real number. Find the identity element. So now they want you to find the identity element. So how exactly do we do that? So we say solution. So the binary operation already was given by a asterisk b is equals to a plus b. So we have to follow the rule for finding binary operation for this and finding the identity element. So we say a asterisk e equals to a plus e, following the binary operation. Okay. We know that a asterisk e following the binary operation is a plus b, right? But we also know that a asterisk e must always give us an answer back, and the answer must be itself. Just like we say this s asterisk e is equals to x. So in fact, what I normally do is that I will say, from the identity element stuff, we say that a asterisk e must give us a back. Then we now follow the rule and say, what does a asterisk e mean? We say a plus e. That's what it means, following the binary operation, and it gives us a. So what do? We take this a to the other side to look for e. We say e is equals to a minus a. And what does a minus a give us? 0. So that means that the identity element is equals to 0. Do we see that? So let's move on to another one. So let's say, for example, they say an operation is defined on the set of real numbers R by, you have the operation to be a triangle B equals to AB over 3 for all A, comma B are members of R. Find the identity elements. So here they want you to find the identity elements as well. So given a particular binary operation. So the binary operation they gave was A triangle B equals to AB over 3. So how do we find the identity element? We'll return to the rule that says that okay, x asterisk e will give us x again, so in this case we know that any operation we perform on the identity element, let's just take this left element to use to test it. A operation e will always give us a back, right? Any operation you take on the identity element to give us the operation back, the number back. So if you now follow the rule, the binary operation rule here, give us a e over 3 is equals to a. Now do we solve for e? First of all, cross multiply. Say a e is equals to 3a. We divide by a, cut, your e is equals to a cut a, and your e is equals to 3. So that means the identity element is 3 in this case. Okay, so let's solve one more example on identity elements. Alright, so let's focus on this. This one says the operation asterisk on the set R of real numbers is defined by x asterisk y equals 2x plus 2y minus 1 all over 2 for all x, y are members of set R, and set R says the real numbers. Find the neutral elements in R under the binary operation. So this is a given problem on binary operation as well, and they want you to find the neutral element. Now neutral element is also called identity element. So neutral is equals to identity elements here in this case. Whenever they can call it neutral or identity elements, but most cases you will always find it called the neutral elements. The identity elements, sorry. So how do we solve for this? Because this tells us that the binary operation x asterisk y is equals to 2x plus 2y minus 1 over 2. 2x plus 2y minus 1 over 2. So we do the same thing, of course. So we know that since x asterisk e must give us x again, they will now follow the rule using this case. You know your x is x and your e is now y for the rule. So we have it that your 2x plus 2e minus 1 over 2 must give us x again. So when you cross multiply, you have that your 2x plus 2e minus 1 must give us 2x. So if you take 2x to the other side, we have that 2e minus 1 equals to 2x minus 2x. So we have that 2e minus 1 is equals to 0. So if you take 2e is equals to 1, because if you take it to the other side, you divide by 2, your e is going to be 1 over 2, like that. So I hope that is clear, and if it is clear about that, let's move on to the other thing we have today, which is the inverse elements. The inverse element also really depends on the identity element. So if you do get the identity element, then we can build on top of it for the inverse element, and let's work with it. Alright, so let's deal with the inverse elements, the inverse of a binary operation of x in a given binary operation. So let's deal with it from the real number sense, because of course we started with the real number idea for it without talking about the binary operation. So in the binary operation for identity elements, I told you that let's say we have in normal mathematics this time around, you say 0 times 1, it will always give you 0 back, right? And 1 is the identity element there, because any operation you perform on 1 in terms of multiplication, you always get 0 again. So what do we have for inverse element? What analogy can we use for it there? So in this case, let's say we have 9 is multiplying a number to give us 1, for example. 1 is the identity element, remember, in terms of normal mathematics. So how do we have it follow? Let's say we have this x, what could it be? You have, by the time you solve and divide both sides by 9, you have that x is equals to 1 over 9, which can also be written as 9 raised to the power minus 1 if you follow the law of indices. So this 9 raised to the power minus 1 is known as the inverse of 9, because if you say 9 times 9 raised to the power minus 1, you will have 1. That is because 1 is usually called the inverse or the reciprocal of 9 in the normal mathematics. Now, in binary operation, we have very similar rules. The rule is that if it operates a binary operation on, let's say, of x on its inverse, you must get the identity element back, because I told you 1 is like the identity element. So if you see this rule and this one, they kind of look similar. If you take x and its binary operation, you will get the identity element back. So anytime we have to solve for inverse, we must first of all know the identity element. It depends on it. That's what it depends on. Do we get that? So x asterisk x inverse must give us the identity element. So without even talking too much, let's solve a question on the subject. Alright, so let's carry on. It said a binary operation asterisk is defined on the set R of real numbers by a asterisk b equals a plus b minus 2 for all a and b are members of set R. Find the inverse of the element x as x, which is also a member of set R. So how do we solve this problem? So let's start with this. Now, of course, let's write the binary operation first. We have that a asterisk b is equals to a plus b minus 2. In order to solve for inverse, you must always have the identity element first. Now, how do we solve for identity element? You must first of all say, oh, okay, we know that a asterisk e must give us a again, right? So let's now follow. We have that a plus e minus 2 is equals to a. We follow the binary operation rules. So let's take everything that is not e to the other side so that we can get our e. So we have e is equals to a. Take a to this side is minus a. Take minus 2 is a plus 2. So we have that e. We can write it here that e is equals to 2 because a minus a is 0. So that means our e is equals to 2, and that's the identity element. So once we have the identity element to be 2, we can now solve for the inverse by applying this rule. And then for inverse, they told us to find the inverse of x. So that's what we are going to have. So for the inverse, we will say, oh, okay, x asterisk x inverse must give us the identity element. And what was the binary operation again? The third binary operation is a asterisk e is a plus b minus 2. A asterisk b is equals to a plus b minus 2, so that we can stay at it from there. So x asterisk x inverse will give us e. So we have that to be x plus x inverse minus 2 is equals to the identity element that we got as 2. Yeah, we got that 2. So we are going to have it to be 2. So how do we solve for this? Take 2 to the other side. We have that x plus x inverse is equals to, take it and become 2 plus 2, which is 4. Now also we have to take this x to the other side because we're interested in finding only the inverse. So it becomes x inverse is equals to 4 minus x. That is our answer on that. 4 minus x. That's the identity element. I'm sorry, that's the inverse of x that we've gotten. 4 minus x. You can see it's pretty much easy as well, like that. So let's take another question. So it says, the new question says, an operation asterisk is defined on the set of real numbers r by sorry by x asterisk y equals to x plus y plus 3xy, and they give us 3 questions on it, and let's take it one by one. The first one says, find the identity element e of r under the operation. So this one wants us to find the identity element, and let's get started with it. So if you have the binary operation as x asterisk y equals to x plus y plus 3xy, right? So they want you to find the identity element. So we can just say, oh, x asterisk e must give us x again. Now let's follow the rule. We have x plus e plus 3xe is equals to x. Take x to the other side. So we have e plus 3xe is equals to x minus x. We left everything that contained e on this side. So that's going to be e plus 3xe is equals to 0. So what's common here? We have e to factorize. E divided by e is 1. 3xe over e is 3x is equals to 0. So you can divide both sides by 1 plus 3x over 1 plus 3x. Cut. E is equals to 0 divided by 1 plus 3x will give us 0, because 0 divided by anything must give 0. So now let's solve the other one. The other question says, determine the inverse of an element x, a member of R, under the operation. Now for the inverse, of course, we have something like this. X asterisk x inverse must give us the identity element, and identity element is 0. So even if the question didn't ask us to find identity element first, we must always solve it in case we need to find the inverse. So let's follow the rule. X plus x inverse plus 3x x inverse is equals to 0. Let's take this x to the other side and leave everything containing x inverse on this side. So we have x inverse plus 3x x inverse is equals to minus x. Now let's factorize by x inverse. X inverse is common. Then we have 1 plus 3x, right? Because x inverse over x is 1. 3x x inverse over x inverse, and we have 3x is equals to minus x. Divide both sides by 1 plus 3x over 1 plus 3x, so that you can get to x inverse to be minus x over 1 plus 3x, just like that. Now the part that may be giving you issue is this third question, because it's looking unfamiliar. It said, find the value x, a member of set R, for which no inverse exists. Now what does it mean for no inverse to exist? Now first of all, let us look at it in this sense. We have x inverse is equals to minus x over 1 plus 3x, which is what we got. In what case will our answer never exist? Now anytime we are solving mathematics and we look at our denominator, now if our denominator turns out to be 0, we cannot have our answer. In this case, that's whenever we have a fraction. That's, for example, if you have 7 over 0 is undefined. That's because you cannot divide anything by 0. 6 over 0 as well. Anything over 0 in mathematics is undefined. If you press your calculator right now, it will tell you mass error. And yes, I want you to try it out now. Where's mine? I think. I have it here. I have 6 divided by 0. Tell me mass error as well. So no inverse will exist. This fraction will not exist when this denominator, your 1 plus 3x, is equal to 0. So that's what we're going to take there. So let's solve it. So your question C, the solution to it will say no inverse exists when the denominator and now we know that the denominator is 1 plus 3x is equals to 0, right? Let's confirm. Yes. So 1 plus 3x equals to 0. So you take 1 to the other side and say, oh, we have 3x equals to minus 1. Divided by 3, divided by 3. Your x is now equal to minus 1 over 3. So that means at a value of x equals to minus 1 over 3, no inverse will exist for the problem. So if that is clear, I think everything else is clear. Then you can take on different questions on the matter. So and that will be that on that, the inverse elements and the identity elements. So let me just give you a recap of the rule to find the identity and the inverse element. For identity element, your x asterisk e will always give you x again, and for the inverse element, x asterisk x inverse must give you the identity element. Do not mix them up. I think they are pretty much easy if you know what you are doing. So that's it. We'll catch up in the next one where we'll be discussing on the commutative property, the associative property, distributive property of binary operations. And that's it for now.